Okay, thanks everybody for joining. So this is the Manchester Java community. My name is Nick Ebbett and I help organise the events and lead the community. Yeah, this evening we've got, we're part of the Quarkus World Tour, which is quite exciting. And we've got Steve and Georgios joining us to talk about Quarkus in a bit more detail. First of all, I'd just like to thank our sponsors. So we're sponsored by RecWorks, who are also associated with the London Java community. They cover our meetup fees, so we really appreciate that. So thanks to them. But yeah, without further ado, I'll hand over to the Quarkus team.
Thank you. Cool. Wow. So thank you. I have some slides. So let me just, of course I have slides. Which one am I going to show? That one, I think. I've learned so many different ways of presenting with different technologies. Right. What do you see? Because I can't see it.
Quarkus in a browser.
Excellent. Quarkus in a browser. There we go. The new thing. Okay. So we have slides, of course. Bear with me as I find my mouse because it's disappeared onto. Where's it gone? There it is. Oh. I have too many. There we go. Right. Okay. So first thing, thank you for letting us come along. The Quarkus Roadshow, World Tour, whatever you want to think about it, is an attempt to give you some more entertainment. And I'm sure we're all suffering from lockdown one way or the other. I know us poor Brits have had it, as bad as anybody else. So part of this deal is we would like to make it fun again to have a meetup. So rather than you watch somebody a recording, we want to give you some fun, and the fun comes from watching people just talk about stuff, but more importantly, show it off. So Georgios is going to do a bunch of code demos, and when I say demo, I mean they're just going to show you just coding. So what's really important is that you participate. So the way this is going to work, I've got a little slide. Here it is. Okay, so blah words, but basically we'll introduce ourselves in a second. I'm going to do some slides, which is the really basic intro to Quarkus, just to get you going. We'll do some demos, we'll do some more slides, but mostly this is what I would call a code jam. What we would like you to do is ask some questions about anything that you pops in your head about Quarkus, and maybe we'll even be able to show you that in code. And then at the end of the session, if there's any questions left, we'll answer them. Now, because of this mode, the way to ask questions is to put it in the chat, and we'll all try and figure it out. So Nick, if you see any questions, and then just shout them out so that we don't miss them. Don't worry about interrupting anything. We'll just deal with them as we come through. Okay, right. So who's on stage? I feel like that's a joke there somewhere. So I've done a couple of things at Manchester Jug over the years, but not very many. So Steve Paul, I am the Red Hat developer advocate for Quarkus. I'm the Quarkus community manager, which means trying to create more of these events. And of course, I used to work for IBM for a long time doing JVMs and stuff like that. But now I'm doing much more fun doing this sort of stuff. Georgios, do you want to introduce yourself, please?
Sure. Hi, folks. Hi, I'm Georgios, or just George, as is the English translation. I'm a Quarkus core developer. So I've been working on Quarkus for roughly, I would say, like 2 years now. I've been doing all sorts of stuff like testing, Kubernetes, Spring, various stuff here and there. So hopefully I'll be able to answer your questions, and like Steve said, if we can, try to actually code some stuff as well. So hopefully you'll get a good overview and good like hands-on feeling of what Quarkus is.
Yeah, cool. And when you say we, you mean you. You'll be coding, yeah. So the other thing, as I've said it again, and I'll keep saying this, ask questions, because it'll be more fun if you do. And even if we don't know the answers, we will get you the answers, okay? So ask questions. So because of this, is with the assumption is that the majority of people on this call will have heard of Quarkus, but maybe not have tried it. So we're not going to go into deep things. If you want deep dives, if we say something, can you come back and tell us more about how Quarkus and Kafka works, or how Quarkus and AWS Lambdas work, or whatever, then reach out and we'll come back and do something in more detail. Right now, this is more to give you a flavor and just give you a sense of the fun of Quarkus. Right, where've we got that one? Okay, so I'm going to do the boring bits at the beginning to get you up to speed, and then we'll hand over to Georges. Right. So why Quarkus? Well, before we even talk about Quarkus, you have to talk about three things that are going on in our lives as Java developers. They're nothing new, they're just getting more intense. So we're always being told about we have to make our applications performant. And of course, now we have to be not only performant, we also have to fit the new economical pattern that you get with cloud. Now, you know what it is, but we'll have a couple of slides in a minute. But basically, the way you used to tune your applications for traditional Java doesn't necessarily work well in the new cloud model. So you have to think about producing applications that perform differently. The place that you run your code is changing, a lot more choices. So, and it's yeah, you got your traditional stuff, and if you've got a vSphere thing and you're running big fat application servers, cool. You might be doing Cloud Foundry. You might be doing some sort of serverless, of which you've got multiple choices. You may have gone and picked up one of the proprietary cloud implementations where you can put your Java in a place. Or more likely, you're putting stuff in Docker containers and running them on Kubernetes. Or more likely, you're doing all of those things. So these are new challenges. How do you deal with all these different environments? Okay, and we'll talk about how Quarkus can help you with that as well. And then the third one is the one that has always been a pressure, but nowadays the time to value. How long have you got from needing to start something to actually delivering value for your organization? Is obviously just gets tighter and tighter and tighter. And cloud has been making promises about how much quicker we can make things happen. So the next question is, as a Java developer, what could you do to make yourself more productive? Okay, so Quarkus comes at this from a different point of view. I think what I like so much about Quarkus is that the people responsible have taken a step back and looked at these sorts of problems and said, how would you deal with them if you were starting again? You know, let's look at this differently. So things we're going to talk about is Quarkus is here. It makes your code Kubernetes aware. So you take your code and you want to make it run in a new environment like Kubernetes. We make your code more Growl friendly. Now, you know about Growl. Growl is this thing that lets you take your Java code and compile it to native. That's not as easy as it may sound. And so actually having something to help take your application and make it Growl friendly, we'll talk about later on, is really important because it makes your life easier, makes you more productive. Performance overheads. How do we give you an application that performs the way that it needs to in the cloud? Quarkus will help you there. And amazingly, it gives you amazing productivity because the Quarkus team have looked at not only solving the problem about how do you make it faster in the cloud, but also thinking about you as a developer and what your pain points are when you're in these new environments. And so built into the whole premise of Quarkus is this idea that you are as important as the code that you produce, and much more. Right, sorry, down arrow. No. Aha, okay. So a few bits and pieces. Because the modern Java applications run in containers, and because the biggest place that containers run is Kubernetes, Quarkus starts there. And so everything is about this idea that you're probably, I don't know, pick a big number, 80, 90% of the time, going to be producing something that runs in a container now. And you're probably going to run it in some sort of Kubernetes environment. And even if you're not, it turns out that if you tune your system for that assumption that you're running in a container on Kubernetes, Even if you don't do that, it turns out although all that premise still offers you performance benefits, etc., even if you're not doing that. So it turns out that thinking about things from a Kubernetes container point of view first makes everything else better. So that's why we talk about Quarkus being Kubernetes native, because that's the focus. We don't talk too much about cloud native, though obviously cloud native is a term that gets associated with what we're talking about. And the reason we don't talk too much about cloud native is simply that cloud native encompasses things that you might go, well, if I'm cloud native, and actually you look at some of these things, some of the older tech, some of the older PaaSes, like the Cloud Foundry approaches, is that if you tuned for one of those, it would not be optimal for Kubernetes. So yes, Quarkus is cloud native, but actually, as I said, we'll talk about it being Kubernetes native because that's the best place to be. Right. So performance, this is the only performance slide that I put up because performance is really important to your business. It's not necessarily super important to you as a developer, right? Other things are important to you, but it's really important to understand what Quarkus is offering you. Now, there's some numbers in front of you. If you look at the top line, you've got a green, a blue, and a gray box, and you've got two sets. The gray box is the traditional application, and you can see how much memory takes. There's a couple of examples, basically different types of application. But you look, the gray box, I'm going to squint now. Gray box on the left says 136 meg of memory, right? So that's not just heap, that's other memory as well. That's whatever your application is really using. So if you take your application and use Quarkus with a standard JVM, nothing special, you get, I don't know, not quite half that. Well, yeah. And then if you really, really care about memory, then you can make the next thing and take the JVM and compile to native, take your same code, apply it to native, and look, you get 12 meg. Right? And that's just a pattern that you see repeated over and over again. You can see the other numbers. Because of the way that Quarkus works, this thing sort of just happens almost by magic, right? So one of the things you want you to take away is Quarkus, it's not a tool to compile your Java application to native. It will do that for you, but that's only part of what it does. And if you don't need native, then don't go there, because you can get great performance just by running a standard JVM. And then the other thing is startup, because obviously a new world, startup is really important. And you can see the same sorts of numbers coming out. Take your favorite application server and say it starts up in 4.5 seconds, switch over to using Quarkus with a standard JVM, and you're down to less than 1. And then if you compile to native, you're in sub-millisecond type performance. It's just bonkers, right? And we'll talk about why that is important and how that happens in a minute. So performance is awesome. I just love how going along we have to use that word, and it is awesome. Once you start using Quarkus, you'll be going, why won't we using this all the time? Because of all these things. So Quarkus is there taking your application and working out how to best to make it work in this environment. Okay, it's going to give you these great startup time. It's going to give you these great memory reduction when you need it. It's only optional that you use Growl. If you don't need native compilation, then you don't need to do it. You just use your standard JVM, which is not Java 8 anymore, is it, George? It's what's the least we support? 11.
Yes, absolutely.
Yeah. Yes, but basically, if you've got a JVM, Java 11 upwards there, and you just switch over to using Growl, you get this performance. Right? And you're going to say, this is impossible. How is this possible? And I'm not going to answer the question, because I want to talk about something else. Or in fact, I'd like Georgios to do a demo in a second, because I said right at the beginning, we're looking at the holistic thing about being a developer, and there's more to it than then the performance of your application. There's also this bit, which you may have heard about, which is called developer joy. So I'm going to stop talking there. I'm going to stop sharing because I have to. If I can find my mouse. So this is where the slick bit goes. I can't. Nope, I've lost my mouse. Can you? Oh, there it goes. Good grief. Right. Stop now. Okay. I'll hand you over.
All right. All right. Thanks a lot, Steve. Yeah, Steve gave you like a good overview of what Quarkus is, what it stands for, but he stopped short of like what the most important thing we think is, which is developer experience. Because what he really wanted to do is he wanted to actually for you guys and girls to see it in action, and that's what I'm going to try to do right now. Okay, so I'm going to share my screen. Is my screen showing?
Yes.
Excellent. So how do you start with Quarkus, right? So there are various ways to start with Quarkus to generate a Quarkus project, but what we usually tell people that the easiest way to do is to go to our website, code.quarkus.io, and in there, depending on what sort of project you want, like a REST API, a reactive application, a messaging application, or Hibernate application, whatever you have a whole bunch of options to select from. Like you could select like our REST Easy, our JAX-RS implementation, and use Hibernate, or you could go ahead and use Kafka. And anyway, I'm not going to do that right now. It's super easy. Just put the information you need here. Select the extensions is what we call them. So those are basically the capabilities of the application, and you generate the project. But I've already done that. And what I did is I'm using a Maven project generated from the website. And what I want to do is when we develop in Quarkus, so when you're like an application developer and you're writing code using Quarkus, what you would do instead of what you regularly do with like other frameworks or toolkits or whatever, where you have to compile and run stuff or use the IDE or stuff like that, and rebuild and everything every time you make changes. Here we have a special mode called Quarkus Dev Mode, and you launch it by using mvn Quarkus Dev or the corresponding Gradle command if you want to use Gradle. But what that does essentially is very simple. What it does is it launches the application, which here for my use case, all it's doing is returning hello. So I'm implementing a JAX-RS endpoint. For those of you who haven't seen JAX-RS before and are like familiar maybe with Spring Web, this is super similar. Your Spring knowledge transfers pretty much one-to-one to JAX-RS. So this should be very familiar. Like it's just a class that answers on /hello and returns hello when hit with a GET request, which is what I'm doing here. But what's the magic here, right? Well, why do we keep on talking about this developer joy and everything else? Basically, it boils down to like the most fundamental thing is this: I change something in my IDE or my editor or whatever. It could have been using Vim or Emacs or whatever. I just refresh, and I immediately see the change, right? So you don't have to configure anything. You just launch Quarkus Dev and you start coding. That's the promise and what the experience that Quarkus is trying to bring to all developers out there is that you focus on the coding, and Quarkus takes care of all the boilerplate of restarting, recompiling, all that stuff, so you don't have to worry about it. And you're probably thinking, well, yeah, you just changed a method signature. That's no big method implementation. That's no big deal. Well, let's make it a little more interesting. Let's do something like greeting. Let's add a new endpoint, call it greeting2. Make that a get as well. And let's also use like a query param. Let's say name, string name. This I'll use a different path. I'll say 2, and I'll go hello name. And let's see, hopefully when I hit hello/2, I get hello null. Yeah, that's not really cool. So I'll add another annotation, which is the default value, and I'll say world, and I'll also add a space here, and I'll get hello world. And if I do name equals Manchester, I'll get hello Manchester. I didn't spell that correctly, but I think I can get that. Excellent. So basically, you see what we're talking about, right? Basically, I'm not limited anymore by how fast or slow I can rebuild the project or rebuild the application. I'm only limited by how fast or slow I can personally code, which in this case isn't that fast, but oh well. Let's say you're like, okay, yeah, I'm sort of convinced. This is kind of cool. You added annotations, you added a method, but can you take it a little further? And the answer is you can take it to extreme. You can make it you can make any arbitrary change you want. So let's say I wanted to use a CDI bean here and inject. I'm going to say private final greeting service. I'm going to inject this. This is a CDI injection here. And I'll say, oh, let's get rid of this. This isn't useful anymore. And I'll say greeting service, greet. Actually, let me get back the old method and use that one instead of this one. And I'll say here, I'll say greeting service, greet. And I'll say name. And I'll create a method, greet, which is great. And I'll say return, this should have been string. And I'll say return hi name. And I'll return this, and I'll get rid of this. So basically what my objective was here is to move, let's say, the business logic I had into this greeting service, right? And this is a new class. So theoretically, in the old model, I would have to rebuild everything, restart the server, whatever. But with Quarkus, you don't have to do that. It's just so much better. So if I go hello 2 and I refresh, oops, I got an error. And I got an error because I was intending on making this greeting service a CDI bean, but Quarkus is telling me unequivocally that you made a mistake. There is no bean of type greeting service. So this error here is very, very clear, and it's actionable. It tells me what I need to do in order to inject the greeting service into the greeting resource here, which is the target. So basically, if you're familiar with CDI or Spring dependency injection, you know that the mistake I made here was that I forgot to annotate this with singleton in this case. And if I refresh, then Quarkus automatically knows, wow, everything's fixed and everything just works again. And that's awesome. So what's the next thing you could do to show what's next thing I could do to show you that, yeah, I can take this as far as I want, right? I'll say I want to get rid of this part. I want to make this a prefix. So I'm going to say private final prefix. This isn't going to work, obviously. So I'm going to use dependent constructor injection here, but I'm going to get the property, the value actually of this prefix from a property. So what I'm doing here is using microprofile, microprofile configuration. So microprofile, if you haven't heard of it, is a set of specifications based on various experience that we the Java folk have obtained over the years, and it tries to address various common problems that we have in this cloud native world, like configuration in this case. So basically, it's a set of annotations that will take capabilities that you probably already know about in Spring if you're developing in Spring, but it uses like a spec. It defines a spec and has implementations. So your spec, you can like depend on something that's defined by a spec instead of totally proprietary like Spring. And here, Quarkus uses application properties to configure everything. So you don't have to worry about all this stuff. This is for later. What you care about here is that the greeting prefix I added here came from this field here. So I configured it, greeting prefix, greeting service now uses this prefix. Let's hope. Yes, that's great. And if I refresh, I'll get hey, because that's what was in application properties. And if I change that, I should see the same thing as well. So I hopefully this like first demonstration showed you that with Quarkus, you can develop very, very rapidly and not have to wait for any like super slow application startup time, or having to have a like a workflow of like, yeah, what am I going to do? When am I going to run the application? Stuff like that. Everything just happens really, really quickly.
So,
So
yeah,
yeah.
so every time you do this, I want to do the replay. I want to do the slow-mo replay because it goes too fast. So just explain to people what gets reloaded, because you're not rebooting the whole application, are you?
Okay, so if we want to get really, really technical, what that means is that we are taking the code that is part of the application. We're creating class loader with that code only. And every time I'm changing something, what happens is that Quarkus can drop the class loader that contains your code and create a new class loader and use that with the new updated code. But it happens so fast that you don't see it. Basically, it happens in like, I don't know, 100, 200 milliseconds, something like that. It should say, I think it says it. Yeah, it started in 300 milliseconds. So basically, you don't really see it by the time it happens.
Right. So, but my point is that if you had a really big application, you'd still get the same very fast load time.
Yes, this scales very, very well. I mean, it might not be 300 milliseconds, but it'll be really, really good. This solution scales really, really well because everything after you've done the first, after everything has been loaded the first time, then the class loader reload and the build time optimization that Quark does happen really, really fast. So this just works amazingly well.
Cool. So we already have a question. And the question is, so basically it's, does Quarkus have everything that Spring does?
Well, everything. Spring has stuff that Quarkus doesn't have, and Quarkus has stuff that Spring doesn't have, because that's just the way the ecosystems are. But I would say that almost everything you would use in like 90 or 95% of the Spring use cases, you will find in Quarkus. They perform much, much better. They do compile down to native because everything that we do in Quarkus must compile to native with Growl VM, and they support this live reload mode, right? So, and if there's something in Spring that might not exist in Quarkus, then we want to know about it. And if it like suits a real need that developers have, then we'll gladly implement that.
Yeah.
But there's something I can think of like off the top of my head that doesn't exist.
Yeah. Well, I said the design choices here are all driven by this: where do you want your Java code to run, and this idea of the Growl story. So if there's something in Spring that we haven't got, it's more likely because it's not a good thing to have, not a good thing to make use of if you're going to go to Growl and things like that.
Yeah, so yeah, exactly. Like Spring has a long legacy. It's been around like what, for 15 years, something like that. So not even everything that Spring has now you would use in a Spring application. So, and a lot of that stuff, yeah, some of that stuff in Quarkus, we might not have it because it just might not make sense in a cloud. Like, let's say we don't have session replication because you don't really use sessions in the Java EE manner anymore with microservices, right?
Yeah. So we have another question. And so I'll read this one. Is the class loader bean level or more separated? And then in brackets is it fine tunable or is it not logical to think on that at all?
Okay, yeah, I think I understand where this is going. So as a developer, you don't have to think about it at all, right? So gone are the days where, yeah, you would see these weird class loader problems where in your application server and stuff like that, you don't have to think about that in Quarkus. I only mentioned the class loader because like Steve asked like how this is implemented and how it scales. You should not have to think about that as a developer. All you have to think about is that I'll write my code against like JaxRS, CDI, or whatever. And that, and Hibernate, stuff like that, Camel. and it will just get called and it'll be put in the proper class loader and it'll be restarted the way it's supposed to. You don't, as a developer, you don't have to worry about that. If you're like a super advanced user and you want to write your own extension, then in some cases you might have to think about it. But then, even then, usually you don't.
Yeah. Okay. Right. Okay. So we'll come back. We'll talk about extensions later on.
Mm-hmm.
So if you can stop sharing.
Yes, absolutely.
I will.
There you go.
Thank you. Let's see if I can share again. That one. Okay. Right. So where do we get to? This is the last set of slides, I promise, apart from right at the end. Now I've got to find my mouse again. Okay. Right. Cool. How was this possible? Well, we talked a little bit about it, but basically my tongue-in-cheek answer is that Quarkus looks at this and goes, you don't need that, so we're not going to use it. It's taking out the bad code, and that's not the right word. So the unnecessary code, and even that's very glib. So I'm going to talk through what's really conceptually what's happening and give you something to help you think about it. But even the example is very simple and contrived. So you will have seen shapes like this. You will have seen graphs about performance, and these are the sort of graphs you get from benchmarks, and they all have the same basic pattern, which is over time, the red line, which is the throughput of your application, reaches some maximum number. And those of you who've been around Java enough will remember all the time where we go, we're tuning our application to stay up and run forever. And therefore, we're all willing to spend startup time, how long does it take for the system to get going? We're willing to do that all at the beginning because it gives us the best performance throughput, which is why we have these shapes. And the white line is the memory consumption that goes with it. And as things come along, as we go from nothing to a running application, we spend CPU giving you the throughput, and we also consume memory to do jitting and stuff like that. So you get these sorts of shape. And the problem is we want a shape more like this for cloud, because we're all kind of conscious about the memory we're going to consume, and we also need to have it starting like this. We're not willing to wait long for applications to start because they're not going to be around that long, and so we need it to be running as fast, up and running as soon as possible. And the reason that the shape is the way that it was is because there's two things going on. There's running all this initialization code. So this is your application's initialization code, and the JVM and the frameworks. And then there's a whole bunch of time is spent turning that Java code into machine code. There's a lot of expectation about what your application is going to be doing eventually, and it's all being prepped for. Okay. So if you want to take one shape performance profile and turn it into the other one, you have to think differently. So I said, there's your application running on, there's a whole bunch of initialization happening, and then there's jitting. And all this needs to happen at the beginning and over time to get you to that fast starting application. But if you think differently about those steps, you can probably begin to think about it and go, well, there are certain things that we do at runtime that are always the same, but we code as if there are different choices could be made, but in fact, it's always the same choice. So that means start thinking about the aspects of your application and going, what could I do not at runtime, but before runtime? What can I do at build time? So Quarkus looks at that from that point of view and goes, we have a build time process, and this is partly Quarkus and partly Growl, but it's the same idea of what code can I run at build time so that I don't have to write initialization. And the JIT's on there because obviously you could do native compilation and you do AOT type thing. And there are other things you could do, but basically there's stuff that takes place during startup that we could do before and try and leave as much as possible into for your application to just do its thing and not have to spend all this CPU getting your applications ready if we can do that at build time. Now, the catch is that a lot of what we do at initialization is all based around this idea that everything's going to be dynamic. and that you can't make a choice about what you're going to do until you bring up the system, whether that's loading classes, looking at configuration files, you name it. There's a whole bunch of stuff that goes on. And we don't know what we're going to do until we do it. So we have to think about that. The other problem is, in terms of performance, is that if you don't do any jitting, then you're not going to get any performance. And if you don't do the re-optimization type jitting that happens as your application gets profiled, then you don't get the maximum performance. So it's not a panacea to take your Java application and turn it to machine code, to compile it to native under all circumstances, only if the profile that it gives you works for you. If you still need the big performance, you might need to still do jitting, but you can still benefit from this thought process of taking out stuff that you do at initialization that you can do at build time. Okay. So quick step about Growl, because I mentioned it. A lot of people go, yeah, Growl, it's this thing for compiler to native, and maybe you don't think much more than that. But it's really important to understand that Growl is an amazing set of technologies, but what it's doing is reimagining the way that Java should behave to allow it to compile things to native. And for that to happen, if you want to make use of Growl with your existing Java code, you have a lot of sharp edges you have to deal with, lots and lots of nasty little bits and pieces. And the thing that Quarkus gives you in this whole mix, because of the way it's reimagining the way that Java should behave, your application should behave, it's saying, we can deal with that through you. So actually, you've got Spring code already, you can move it to Quarkus, and you're probably not going to have to do anything else. So I've got some pictures here. You'll have to bear with me because I'm working my way through this in my head to try and make it easy to understand, but do a shout out if it doesn't make sense. So whereas before we had standard JVM and we had a runtime and everything took place there, we're now saying split the standard mode into two parts. So there's what happens at build time, that's your initialization, and then generation. And I'll show you an example, well, rather a Java example. It's not a real example, it's just to give you an idea. So we're now saying do things at different parts of the process. Do what we can at build time, minimize what happens at runtime. And the positive outcome of this is that makes consumption, moving into Growl and compiling things into machine code even easier, because we've done a whole bunch of heavy lifting that you need to have happen for Growl to make use of your code. So these really bright pictures, I'm going to try and explain. I said about initialization, generation, and then runtime. Quite often we write code that looks like this. Well, it doesn't look quite like this, but the thing is there. You'll do something like you're going to go off and get some system property, and it's going to tell you the name of a class you're going to load. And then you're going to try and do a for name on it. And then you're going to try and instantiate it, and then you're going to run it. So you've got configuration, you've got initialization, and then you've got execution. And that we do a lot. But Quarkus sort of doesn't think of it that way. So the way Quarkus would like you to think about it is more like this, which is more about thinking about what the default case is and talking about going, well, if I know what the answer is likely to be, I can tune the code towards that. So rather than go, I'm going to look up a configuration file and look for a class name and go, hey, surprise, it hasn't changed, and go through all that. If you don't think that way and you start thinking about trying to work out what the default answer is and then deal with it, you get better performance. And of course, the Quarkus then starts to help you separate these initialization and generation and runtime into better structures to allow you to get the performance you want. Okay, so that example I put out there is not what Quarkus does at all, but I'm just trying to get you to think about how you write your code and how you would write it differently if you wanted to get the performance, and just let you know that Quarkus is sort of doing that sort of thing for you. And so I think I've said this, basically by putting in this characteristics, applying these characteristics to your application and giving you this init stage and this generational stage, it lets us do this compilation to native and much easier, makes your life easier. But of course, it also means you can choose whether you want to use a JVM or both. Okay. So I just said this is generic, works for all code. So Quarkus is not a compiler native tool, right? That's just one of the things it offers you.
Question,
And then,
Steve, if that's all right.
Yeah.
Yeah. So this might feel free to kind of tell me to be quiet if you're going to come on to this, but just interested in what the trade-off is then around pushing kind of more of the build, kind of let's say around creating a native image earlier in the process, like moving it away from, I suppose, deployment optimizations to build time. So with the trade-off in terms of like time, I suppose, more than anything.
I'm not sure how I would answer that. I would defer to my colleague. He's probably got a good answer.
Okay, yeah, no, that's a good question because when we're talking about Growl VM, there's one very, very clear trade-off, and that is that it takes a long time to compile a Growl VM, a Java application, pass it through Growl VM to make the native binary. That takes a while, right? We can see it on my machine immediately, like when I do the next demo. That takes a while. The second trade-off is that not everything that spec compliant Java JVMs can be done in Growl VM. For example, there is no way to load a new jar into the native binary and have those classes loaded. Everything that's going to be loaded, that can possibly be loaded, needs to be known when you're actually building the native binary, right? So that's like one very, very prominent example. And that's what Steve meant basically when he said that Growl VM is like reimagining what a Java application needs to do when it in order for it to move to native, is that some things that we consider in Java, well, actually, like advanced Java users know that the JVM is like super, super dynamic. You can do anything. You could like read classes over, you could read bytes over the network and create classes of it from it. You could drop classes. You could do anything. You can instrument it. You could, it has all these like super advanced hooks into it that tools can use and stuff like that. All that stuff, or most of that stuff, goes away completely when we're talking about a native binary. So, for example, you can't attach agents, right?
Yeah.
So that's what I would say is the most important trade-offs.
Because what Growl is doing is it, and you'll hear this term, it's this closed world assumption.
Yes, exactly.
And the idea is that you give Growl all the information it needs to understand what your application is going to do, and there are no runtime deviations from that. You know, you can't load classes, you can't replace classes on the class path because there's no class path. You know, it's a completely different thing. So given that, but also given the fact that we write code with we've all been brought up to write Java code with the assumption that we can just do this, and we can have classes on the class path, we can do reflection and stuff like that, and we just do, right? So if you look at some of the extensions, and we'll talk about extensions, but the idea is a lot of this is it's more to do with the developer convention about how things behave rather than anything else. So it's not impossible to understand that you can look at a piece of code like I showed, you know, this sort of thing where you do dynamic lookup even when you know the answer is always going to be the same, and do something a little bit more useful that says, I look at a property and if it hasn't changed, I'm going to use the hard-coded version, otherwise I'll do dynamism. So I said that's not the brilliant example, but that sort of mentality is what we're looking at and going, how do you take that approach and boil it down into the extensions of things? So that's what Quarkus is doing for you. There's code generation going on, and the extensions are adding the smarts to say, I know how to understand what your dependency does. Right? All these dependencies, they all work differently. So Quarkus has extensions that means that Quarkus understands what those what all your dependencies are going to do and gives you this boost. And I'll shut up there. Right. So let me just finish this off, and then we'll go off and do real code. The other thing is, you saw the demo, the developer joy demo. Well, so that's in there too. So what you've got now on your screen is a picture with some nice yellow lines. But you imagine we've all got this. We've got a code, build, and run, and that's our life, right? And you all know just how long that can take to get the complete answer. And it's just, that's not very good when your runtime has to be deployed into a container or even onto Kubernetes. So it gets horrible when you've got to have all these steps in your process. So what Quarkus is giving you is this dev mode, which is this thing you saw, which is an extra step effectively. And dev mode, as George says, runs in the VM that you're running. So it's in dev mode. This is not production mode, right? And so what you've got is a whole bunch of smarts running in dev mode, which is related to the extensions that we were talking about and this idea of thinking about how your application should behave and putting that into the dev cycle. So that's why all these things are connected. The extensions are there to help you get to cloud to native if you need it. They're there to help you get faster startup. They're there to give you this sort of fast deployment as well. It's all connected. So you just change your code and it just gets compiled by Quarkus, and you don't have to go through that build time process, because pretty much, you can change the POM file as well, can't you, George? You just,
yeah.
I'm not sure you have to come out of it at all unless you want to run packaging or something.
Yeah, you could add and remove extensions, and it will restart. That will be a regular restart, but yeah, it works.
Yeah, and maybe we'll get to show this. So we've talked. So you can now imagine that you've got this dev mode that gives you this. You change the code, it just gets compiled. It's running in your application. And now we're saying, well, also you can do that in an application that's running in a container. And this is the bit that wows me every time is, by the way, that container doesn't have to be running on your local machine. It could be running in Kubernetes too. So think what your joy would be like if you have your IDE and change code and it gets recompiled in live mode on your application, but your application is actually running on a Kubernetes cluster. Would that be good? Woohoo. Okay, look, I'm going to stop talking now because now we want to do some more demos. And now, of course, I've got to do the same thing to get my mouse back. Okay, right. So we've obviously left everybody speechless.
Yeah, like any questions you have, just ask us. The more questions we get, the more relevant stuff we can show for what you actually want to see. So Steve stopped by saying that we can take what we saw earlier in the dev mode and apply that to a application that runs somewhere else in the cloud in order to see see the live reload in that setting as well. So that's what I'm going to do now. This consists of a few parts, right? So basically what Quarkus is going to do here, I'm going to launch this special command, which is just clean package. So package is normal Maven, but I have this extra flag here called Quarkus Kubernetes deploy equals true. What that does basically is that it'll create a Docker container locally, which we'll see happening right now. That happened now. It will push it to our Docker registry. And I've configured the Docker registry here with these properties. So it's using my my account, and it's going to push to Quay. So after it does that, what it does is that it goes, it uses your locally the Kubernetes cluster that kubectl is configured to talk to. It uses that configuration and it creates the necessary Kubernetes manifest. So think of service, deployment, stuff like that. And it applies it to the cluster based on the application you're actually running and the Docker container you created. So once that's done, now that's what it's doing. It's pushing to Quay now, and this might take a little while. But once this is done, it will push the apply the configuration to Kubernetes. Now, I have a Kubernetes cluster running here. This is an OpenShift cluster, but OpenShift is Red Hat's let's say enterprise distribution of Kubernetes. So it's actual Kubernetes, but it has a lot of extra stuff. So this is what this awesome UI is. This is probably like my number one reason for using OpenShift is that this UI is so much better than anything in the regular Kubernetes world. So what happened here is that Quarkus applied everything. It deployed the application to Kubernetes, and we can see the pod is running here. So my application is running. It has a route. So a route is, think of what Kubernetes has in the form of an ingress. The route is just much better. It just works out of the box. So I have this URL here that I can use. And if I go hello /2, I get hola world, right? So that's excellent. With one command, I was able to push my application to Kubernetes. Now, I did have some settings in there, which, like I said, container image. I'm also trusting this API server because this API server I'm using is using a self-signed certificate. And now there's an extra step that I'm going to take. So up until now, I just know that I'm pushing a regular application to Kubernetes, right? And this is awesome on its own because it's like one command, push to Kubernetes, amazing. But now what I want to do is I want to show you that I can actually, if I want, right? So keep this in mind that this is not enabled by default. It's only enabled if you opt into it, that I can use the developer experience I showed earlier with the dev mode. I can use it on the application that is actually running in the cluster. So what I do is I run this remote dev. So this is like, think of dev, but for an application that's running somewhere else. And I'm giving it the URL that I use to access the application. So what that does now, if I change like, let's say the service, and I add this, and I refresh, then I should see that that change is automatically applied, right? So the same type of experience I had earlier locally, I can use on a running Kubernetes cluster. You don't want to do this in production for sure, but what you do want to do this for is, let's say like in a dev environment where it's really hard to have like the various downstream services or dependencies you need running locally, but you do have them in like a dev or test environment running in a Kubernetes. Can use this sort of experience in order to live develop your application against like the real dependencies, right? So I could go ahead and change more stuff. Obviously, I could take this away again, refresh, and the change is there on the cluster. This takes a few seconds here because the cluster like isn't really close to where I am, and it's kind of slow. But if the cluster was like really close location wise and it was faster, then this would happen a lot faster as well. So that's like the dev mode, like taken to a whole nother level, right?
Yeah, I just think that is so amazing. And if you've tried pushing applications to Kubernetes and then try to debug it locally, I mean, or trying to reproduce it and then trying to get all your data connections for the cluster, it's just a nightmare. Whereas what you get here is, well, it's just your code. So somebody said, and I think it's quite tongue-in-cheek, but sort of Quarkus puts the script back into Java. But it does give you that ability, that feel of, you could sit there and sort of play with the code and read the data and see what happens, and just know that you're not in any sort of really long, tedious deployment cycle. You just sit there and try it out and see what happens.
Yeah,
and I think that's really powerful. Yeah.
So I suppose that's just as easy to connect up to a local Kubernetes cluster like Minikube or Kind or something like that.
Yeah, absolutely.
Yeah, yeah.
Absolutely. Same exact experience. I'm just using OpenShift because like it actually shows that it's not on my machine.
Yeah.
And
Yeah.
it's yeah.
Yeah, very cool.
Now, before we go any further, there's a question came in with
Okay.
that Quarkus Native, which says, does Quarkus Native still have network performance issues? It was mentioned in a talk last year from Roberto Cortez at LJC. Does
Not
Quarkus...
that I'm aware of. And I'm one of the people that answer questions a lot on our Zulip chat or GitHub thing. Not that I'm aware of. The one thing that we do know that, but it's not Quarkus specific, is that with Max, if you haven't configured it properly, that localhost sometimes the resolution of localhost takes a while in Netty, so you could be seeing that. But other than that, there are no in Quarkus specific network issues that we know. And the reason is that Quarkus builds on extremely robust foundations, right? So we're talking about Vertex, which Vertex has been around for a while. It's like super battle tested, very good performance. And Quarkus builds on that in order to use its entire, to implement its entire IO layer.
Yeah, so Craig, who's the one who submitted the question, has added an extra one. He says throughput in particular.
Throughput, okay. That's interesting because if you go to Tech and Power, the latest round of Tech and Power, you'll see that Quarkus is way ahead of any other enterprise framework in terms of throughput, right? So if you compare enterprise style frameworks, so not micro frameworks with like functional style configuration or whatever, if you feel like annotation style applications, framework, sorry, then if you compare Quarkus to all the competition out there, we can be like up to double, or we could get up to double the throughput that the competitors can.
Cool.
So yeah, Tech and Power latest installment. You'll see various Quarkus configurations there. And I can talk about like, well, if it's interesting, I can talk about what each configuration means, because it does get a little confusing why there are like 5 or 6 Quarkus entries there. But yeah.
Okay. Right. Well, so I would think it would be good at this point just to have a look at some of the extensions and give everybody an understanding of what's out there, even if we don't go through them too much.
Yeah, right. So like we said earlier, Code Quarkus IO, it's like a visual guide to everything where you pick the extensions. So we have various categories. So there's the web category, there's the data category, messaging, and then core reactive. So let's see, for example, data, right? Because everybody needs to interact with some sort of data store in their application. So Hibernate, obviously the most prominent one. Almost the majority of Java developers have used Hibernate to interact with relational databases. It's there. We have various drivers for various relational databases, but of course we have a lot more than that. We have let's say Mongo support. We have Neo4j support. There's Elasticsearch support. There's of course Flyway and Liquidbase for schema versioning. We have Hibernate Reactive, super new, exciting stuff. So one thing, before I talk about this, one thing we haven't talked about here with Steve is that Quarkus is reactive down to the core, right? So everything Quarkus does is based on a reactive foundation, but you don't have to use that if you don't want to. So you can continue to use regular Hibernate, which uses JDBC under the hood, so blocking IO all the way. But if you want to get the maximum performance, then you can use our like reactive reactive implementation of JAX-RS, our Hibernate reactive layer, so you can get non-blocking IO all the way down. We have that for a lot of our extensions. Kafka, so like I wouldn't say most, but a lot of applications these days use Kafka in order to communicate events with downstream applications. Downstream actually services in a microservice environment. So we have a very great programming model around Kafka, super easy to use. It's reactive as well if you want it to be. Then you have like and you have all sorts of cloud, like Amazon Lambda, Google Cloud Function. So any of that, the really heavily used cloud providers, we have integrations with that to make it really easy to deploy applications there. We have a framework called Funky, which which abstracts away these cloud providers. So you write like a Quarkus specific way of writing the application, like 1 or 2 annotations, and you can deploy to any of these clouds and therefore not be tied to the cloud provider itself. Then we have a whole bunch of observability, like so tracing, metrics, logging, all that kind of stuff. Security, of course, is covered. There's a whole bunch of security options. The one we usually recommend, because it's so powerful and it's really easy to use and super configurable, is Keycloak. So you can basically use tokens with Keycloak, anything like that. And then there's all the stuff that you would use in a regular like application, right? So Jackson and all that good stuff. gRPC we have a GraphQL. So and then for more special needs, you could create command line applications with Quarkus, right? You don't necessarily have to have server side applications. You could create command line applications with Pico CLI if you want. We have we could send emails. There's a whole bunch of there's so many. We have a server side templating engine, and all this stuff works great together. All this stuff works in with dev mode, so live reload and everything. And all this stuff compiles down to native.
Yep.
So anything that is here works with native, or if it doesn't, it's a bug and we fix it.
Yeah, and I would like to point out this point because it's important. Quarkus is not just a web framework, because you don't need to have any web in this. You can do, you want to write command line tools, you want to write stuff that does data manipulation without having a browser involved, fine. Quarkus is all of these things. So Craig has very nicely posted a Quarkus IO blog from July 2019 about the performance. But we were talking about the throughput. But July 2019, how old was Quarkus then?
Very new, very new.
Yeah. So we're going to say it's got a lot better since then.
Oh yeah. I'm looking, trying to find the actual round here. Okay, yeah. So here it is. If you choose Java, you need to deselect this. This interface is so weird. So Java. If I select Java and then go down here and apply changes, then you see that Quarkus is basically the fastest one of these. Anything that's above Quarkus here is like a micro framework or a toolkit like Vertex. Quarkus. So what you would likely use is this Quarkus REST Easy Reactive. So it's our JAX-RS implementation with our reactive JAX-RS implementation. So in terms of throughput, like I'm not going to show like where the competitors are. You probably have to go pretty far down to find them. So in terms of throughput, like we're way ahead of any other comparable enterprise style framework.
Yeah. Okay. And more questions. So those dependencies extensions have only the latest, newest versions always, or how these extensions depends. Okay. I'm not quite sure I get it. So
I think I understand. Basically, the question I think is like how we handle the various dependencies within Quarkus, right?
Yeah.
So there's nothing extremely innovative here. We use a Maven BOM, and in our BOM, so you're not supposed to use like different versions of our dependencies inside the same application, because that's not tested. What is tested is all the specific, like when you use a specific version of Quarkus, like I'm doing now, latest and greatest. There are specific versions of these dependencies that are brought in transitively, and they're all managed by the Quarkus BOM. So this is the same approach that other frameworks take as well, right? So if you're going to use something that is not part of Quarkus, then you can go ahead and use like whatever version you want of that library. But if you're going to use Quarkus with, let's say, Jackson, you should use the Quarkus Jackson extension, which will bring in a specific version of Jackson, and it's usually like the latest, right?
Yeah. Okay. So what's your favorite thing then, Georges? What would you like to demo?
How about we show like what this compilation down to native image actually looks like, right? Because we said it's like super easy. Quarkus takes care of everything. But what does that actually mean? What that means is if I do a package -d, I'll skip the test because they're not going to pass because I made changes. And if the way we invoke Growl VM in Quarkus is that you don't have to do anything. You don't have to set anything in, except in a few cases. In most cases, you don't have to do anything. Just -d native or -p native. What that does is that it'll create the jar, and after the jar is created, Growl VM will be invoked with the necessary flags, right, to make everything work as expected. Now, you don't have to have Growl VM installed locally. I do, but you don't have to. And even if you don't have to, Quarkus will use a Docker container. We use Growl VM and a Docker container in order to compile the application using Growl VM down to native. So, like I said earlier, this application on my machine, my machine is pretty powerful. It has like 16 cores and 32 GB RAM. It'll take about, I don't know, 40, 45 seconds. So that is a trade-off that everyone has to be aware of.
Wow, that was fast.
It's fast, yeah, but if you take it on my laptop, it won't be this fast. So basically, you need to know that because Growl VM is doing, like you said, a ton of work figuring out all the possible like code paths and deleting a bunch of code. This takes a long time, right? But look at what the outcome is. The outcome is if I run the application, the native binary, it starts in 17 milliseconds, right? Which is just crazy, I would say. And if I do, let me do it here. PS RS clear PS RSS PSR. What I'm trying to do here is just show how much memory it's going to take up, how much this native binary takes up. Tour, and it's taking up only 32 megabyte RAM, right? So you can imagine that when you are in a specific use cases that really could benefit from this insane startup time. So 17 milliseconds allows you to react extremely quickly to unpredictably bursty traffic that, let's say, you have on your application. If you really need to spin up, if your cloud provider is able to spin up more instances of your application to serve traffic really fast, and you actually need to be able to do that in like sub 100 milliseconds, then this is really the way to go. And it takes very, very low RAM as well. Another way to use this would be with like command line applications, right? I know I don't want to write Go, like I really don't. So I would, if I needed to write a command line application, I would use Quarkus with Pico CLI, which is an awesome library for creating command line applications, and I would compile it down to native, and then I would just run it. Wouldn't require Java for that native application, right?
So, George, does JavaFX work with Quarkus?
Quarkus itself doesn't have an integration with JavaFX. Now, I know that there are the folks at, what is it, Gluon, I think it's called.
Yeah.
They've done a lot of work with Growl VM and JavaFX, but we just haven't had like the time to.
Yeah. No, I know it's fun. I quite get that, but it just opens up the possibility of actually writing real applications.
Yeah. Absolutely,
Java, desktop applications. Yeah, cool.
Absolutely, yeah.
So there's more conversation around this dependencies thing, and good questions come up, which is basically asking, how do you manage security issues when we've got these dependencies? When we've got a Quarkus dependency on on somebody else's framework, what's the policy for dealing with security issues resolved in those downstream things?
Well, when there is an update in the downstream, we pick it up and we release a new patch version, usually of the framework. Or let's say, let me put it this way: Quarkus release very, very often, right? So we target to have like time box releases. So we try to have a minor version every month. So we release like 113. Let's say the beginning of April or something like that. 112 was like the beginning of March. So you see that we release really, really quickly. So there is like never a significant time between like vulnerability that has been patched in a downstream version and us picking it up, because we have automation in place, and the mentality is really agile anyway. So we do releases very, very quickly.
And it's worth pointing out that this isn't Quarkus being this sort of separate layer on top of all these things.
Mm-hmm.
A lot of the extensions are being developed with the guys who are creating, I don't know what you call it, these downstream dependencies.
Yeah, for sure. We've had a lot of community interest from folks that like with databases or whatever other libraries that come in and create extension, do great work.
Yeah.
And yeah, so it's a community oriented development, right?
Yeah. So another question,
Mm-hmm.
and this is a good one to bring up. Can you talk about the difference between preview and experimental?
Yeah, right. So we have 3 statuses for extensions. It's like stable, preview, and experimental. Stable is what it says, like it's an extension that's been around for a while. We consider the API very stable, so we don't want to break it, or unless there's a very good reason to do so. So that's what stable means. Now, preview means that the extension has been around for a fair amount of time, but not like super long. There might be some issues that we might have to work around or change the API a little. We don't expect to change it much, but we want to reserve the right to do so. Now, experimental means that this is like a brand new extension. We think it's great. We think it does something that people really are going to use, but we are very much not sure if the API that we expose to users is going to be stable or not. So because like when you're coming out with something new, it's great. Like you have ideas and you do things the way you think they should be done. But then if you don't get feedback from users, there's no way to know if you did it right or not. So experimental means like we want people to try it out, but we want people to give us feedback, and we want to be able to change the API we expose at any time before stabilizing the extension. Or like it might turn out, it hasn't happened so far with any extension. It might turn out that like the extension, we thought it was great, but users didn't. Like it doesn't fit any good need, so we might like just deprecate it completely at some point. That hasn't happened so far with any extension.
So that you were good. You just answered the question really, but Craig, who brought up the question, says he likes the templating engine. So Qt, I assume.
Yeah.
Yeah. So okay. And is there any sort of timescales about when things move from one stage to the other?
Not really. So it's basically up to like the extension authors to when they feel like that the feedback they've got from the community is adequate and that the API is now stable. So with Qt specifically, we are going to move it. We're going to graduate it really, really soon because it's been around for a while. And the API hasn't really changed. There have been a few changes, but not many. So as far as I know, we're going to be graduating that pretty soon.
Cool.
So yeah, if you are using Qt, you can be certain that it's not going away, and any major changes aren't coming to it.
Yeah.
Because yeah, it works really, really well.
Cool. Okay. Well, we run out of questions. Got anything fab we could demo?
We could show like really, really quickly what our persistence layer looks like, for example.
Yeah.
So folks might be like used to Spring Data JPA and how Spring does it, like makes database access easier. We have a slightly different take on that. So for example, let's say entity, I need to refresh. Okay. What we're doing here is we're adding what we call our Panache layer, right? So we want to make Hibernate even easier to use for Quarkus users. One way, there are various ways we do this, but the way I'm going to show you here is more like an active record style pattern, which some people hate, others love. You don't have to use it. You can use the repository pattern that you're used to with Spring Data JPA as well. But I'm going to show you something new here. It's for the Java world anyway, the active record pattern. So I'm going to create a fruit. I am going to say fruit resource and say path fruit public list fruit. Oops. And I'm going to say list all. And I'm going to return fruit list all. And I'm going to get. So I'm expecting that under get, I'll be able to return all fruits. Now Quarkus, I have this property here, which is just telling Hibernate to drop and create the schema. Most people are already used to what this does with Hibernate, because Spring does this as well. So we have our own configuration, but yeah, it just basically tells it to drop and recreate the schema. We also have this other convention here that if you have an import SQL file, Quarkus will execute it when the application starts. So I have my fruit entity, and I'm expecting that when I start the application, that it will, I'll be able to see when I hit /fruit that I'll be able to see all fruits, right? That's my expectation here. Let's see if it actually works. Fruit. Made a mistake. Let's see. Oh, right. It's blocking. So yeah, another example of like Quarkus making it very explicit that what you're doing is wrong. So what I did here is that because I'm using a reactive layer for the JAX-RS implementation, but Hibernate is blocking, I can't block on the event loop. So all I have to do is add this blocking annotation here. And if I refresh, I see that I'm getting all my fruits. Now, there is some hidden magic here that I didn't talk about. The hidden magic is that I didn't configure anywhere where the database is, right? So there's no configuration about like what URL to use or anything like that, username, password, none of that stuff. And the magic is that because I didn't configure it, Quarkus automatically will start the application, start a database for me using test containers. So if I find that here, so there it is. So here it is. Quarkus knows that because I'm using a Hibernate application and I've told it to use the Postgres driver, then it knows that, okay, no database is configured, no URL is configured, so the user isn't configuring using their own database. So what I'm going to do is I'm going to start Postgres for you in a container, and you can go ahead and use it with zero configuration. So that's just another way of showing you that Quarkus like really gets what your development cycle looks like. Like you don't want to have to configure 100 things in order to just develop like a REST API, right? You just want to get down to coding. So this is another example of like things just work super easily. Of course, in production, you would not do this. You would supply external configuration, which Quarkus supports in all forms, like system properties, external files, environment variables, reading from Kubernetes secrets, config maps, whatever, config server, like Spring Cloud config server, all that stuff is supported. I just want to show you that like Quarkus has this notion that it's what you do for development is not the same as you would do for production. That is both in terms of what the defaults are and in terms of what the emphasis is on in these two different cycles. So when you're developing, the emphasis is on developer productivity, fast turnaround. In production, the emphasis is on performance, right? And low, fast throughput, low startup time, and small memory consumption.
Yeah. And that's one of the most amazing things that I find about Quarkus is that attention to detail, to how developers think, is across the board. And that, so sometimes it's really hard to talk about Quarkus because it's all these small things, and what you've seen is quite big, and there are lots of little tiny bits and pieces that Quarkus does, because as George said, it's we know how you really want the thing to work in a development mode, and it's just everywhere. It's just amazing. Okay, well, I reckon that we should stop. I'm sure you're demoed out.
Now, if we have questions, I'm glad to take them.
Yeah. I suspect the audience is probably demoed out as well.
I do have one question, actually.
Sure.
So in terms of, I suppose, development styles, people have different ways of working. I'm quite heavily kind of test focused. So I'm interested in if you're working in a kind of quite hands-on TDD style fashion, do you get benefits of the dev mode there? And how does it all, is there anything that integrates there that kind of you can get value from as well?
So yeah, I wasn't going to demo this, but since you asked, okay, here's the kick, right? So you saw that I'm using 2.0.0 alpha 1, right? So this, you should not use this in production, obviously. This is our first alpha version of Quarkus 2.0, which will hopefully release in June, right? And what this includes is what we call continuous testing. So the idea is to take the development mode that you saw earlier, that like everything reloads really quickly and stuff like that, and bring it to testing. What does that mean? That means, like, let's say I have this greeting resource, right? So basically, let's take it from the top, and I go here, and I go string hello, return hello. And let's get rid of all of that. And I have a test here that says when you hit hello, expect HTTP 200 with the body of hello, right? And you see down here it says test disabled. Press E to enable. So I'm going to enable it, and Quarkus is saying running tests for the first time. Now, it actually saw that this is why I wasn't planning on demoing it, because it still has some quirks, but this will work. Like if I clean it and start it over, it'll work. And I'll show you why I think this is super exciting. But it still needs a little bit of polish, because like I said, this is just an alpha version. So what it's going to do, basically, when I enable tests, is it's going to go ahead and run all the tests, right? There's only one test here now. So it's found that there's one test. If I had more, I would have run them all. And it says expected hello, actual hello. So I'm expecting hello here, but here I am returning hello. So if I change this and I do this, then it just automatically ran the tests again for me, right? And it says all tests pass. If I go hello 2, test fail. So if I go public string hello 2 and go get path to return hello, hello 2, and I copy this and go hello 2 and hello 2, hello 2, then, and I say hello as well, and I go hello 2 here. Then when I go here, Quarkus will run all the tests again, and it found that one of them didn't work, and it didn't work because I didn't write it correctly. I just make the change and everything passes, right? So you see that you get the same style of like fluid development. Everything just works, right? And the trick here is that if I had another test, like for the fruit, and I only change stuff in greeting, it would only run these greeting tests and not the fruit test, because it knows, because Quarkus tracks like which test corresponds to which application code, right? So this isn't TDD, but it's what we call continuous testing. It's very fluent, very new way that we think, like, first of all, we've never seen it in the Java world, but we think this could be really, really good.
Well, it could be TDD. You just write the test first.
You could, yeah.
Yeah, it looks very cool. Yeah, I think the things I've seen that's similar are outside of that kind of dev loop. So you might have a wrapper that's watching the file system, and it's still that slower process, I think.
Yeah.
So this looks like the speed of that feedback was pretty awesome, to be honest.
Yeah, that's the point. And
Yeah.
you can't really see it with this small application, but if I had like a big one with like 50 resources and like 500 tests, and I would only want to run the tests that I know are affected by my change, and Quarkus does all that, right? So yeah, we think this is really cool.
Yeah.
So when's that planned at the moment, release?
So Quarkus Alpha 1 is already out, so you could try this right now. You could download it. Well, you can't get it from code Quarkus.io, but just changing the version to Alpha 1 and the bomb to this Quarkus bomb will get you this version. And if you have trouble, like, just ask us on our chat and we'll help you out. But the actual like production release, we envision it to be in June.
Right, cool.
Yeah.
Thanks.
Yeah.
Sure.
Okay, so we have one more last question because it's time.
Yes.
And he said, "What is the relationship to Thorntown? I spotted that name in the blog article."
Right. So Thorntail was, let's say, Red Hat's first attempt, or let's say iteration at making like bringing Wildfly, which is JBoss, like JBoss application server. It was bringing Wildfly, making it smaller, and bringing it to like the cloud native world where users like expect to not have an application server, but have a standalone jar that they run and they put inside a container and things like that. So that was the first iteration. It had some really good ideas, but it didn't really take off. I mean, it did well, but it didn't have this revolutionary idea that Quarkus has, where they do as much as you can at build time, and therefore improve developer productivity and performance. So Quarkus, basically, when it was released, Red Hat middleware moved most of the development effort from Thorntail to Quarkus, right? And got a whole lot more people involved in Quarkus as well. So Red Hat has discontinued Thorntail. If you're a customer of Red Hat for Thorntail, you still get like updates and security fixes and stuff like that, but there isn't any real development plan for Thorntail. All the focus now is on Quarkus.
Okay, thank you. Okay, well, I think we're done. If you want more from us, then just reach out, and you can just go to the Quarkus.io website, and you'll find all sorts of ways of getting out and talking to us. Reach out to Nick and ask him to come to us. Find us on LinkedIn or Twitter. Or if you have general Quarkus questions, just turn up on Stack Overflow, because there's people there as well. And other than that, I'd say thank you so much for hosting us, Nick. It's been fun.
Thank you very much.
Yeah, no, it's been brilliant. Thanks for joining us for this stop on the world tour. Yeah, it's been really interesting. Thanks for everybody for joining again. And yeah, we'll hopefully see you all again soon.
Yeah, maybe in person.
Hopefully, yeah, let's hope so.
Oh, okay, thank you.
Great. Cheers, everybody. Thank you.
Bye-bye.
Bye-bye.